Thank you, Karina. I'm going to be talking about research we did to determine if fire can be used as a tool for the restoration of a very rare annual plant, Amsinckia grandiflora. This is research that was designed by Tina Carlson. Unfortunately, she was not able to make it today. So I'll be filling in for her today. Luckily, I've had the privilege of working with Tina for the last 11 years on this project. Tina is a plant ecologist, and I consider myself more of a land manager, as you could hear from my diverse background. So I'll probably be approaching it from a slightly different angle than Tina was. Okay, so the work was done at Livermore National Lab. The laboratory, and as we refer to it in Livermore, the lab, consists of a main site in the city of Livermore. Let's see if I can get that here. Oops. I pushed the wrong button. I have no idea. Well, it consists of a main site in the city of Livermore and a remote test site. Thanks. A remote test site in the interior Coast Range, right here. You can see here that here's Livermore, and the city of Tracy, and way out in the distance is the San Francisco Bay. The Alameda-San Joaquin County line runs right through the site. So Site 300 was established as a remote test site for the Lawrence Livermore National Laboratory in the 1950s. At that time, the site was fenced off, and there has been no livestock grazing at the site since the 50s. So a little bit about our target species. Large flower fiddleneck Amsinckia grandiflora is a state and federally endangered species. It's an annual plant that germinates in the fall and blooms maybe in the last week of March throughout April and is completely senesced by the end of May. There's actually 7 species in the genus Amsinckia that occur at Site 300. The large flower fiddleneck differs from them in several characteristics, and one of the most obvious is that it has dimorphic flowers. You can see in the picture in the upper corner here is that 2 flower forms. One is called pin flowers, they have the style exerted, and the other is called thrum flowers with the stamens exerted. Okay, as far as the distribution of large flower fiddleneck, there's currently three native populations of the large flower fiddleneck. Unlike the more common Amsinckia species, these are extremely localized populations. 2 are located at the Lawrence Livermore Remote Test Site, Site 300, and a third is located on property owned by the Contra Costa Water District. It's a mitigation property for the Contra Costa Water District. There's also 2 introduced populations of the large flower fiddleneck, one at Site 300 and a second population that is at the northern extent of the historic range of this species in Canada. So this is a species that's really been doing poorly in recent years. So for the last 10 years, throughout its entire range, there's been between 350 and about 7,000 plants total of the species. The 2 populations at Site 300 have had no plants for the last 10 years. So for about 10 years, there's really been one viable population of the species. As far as threats, all the populations, the introduced and native populations, occur on protected lands. So the threats are not obvious. They're not really visible what they are. And anybody was in David Ackerley's talk yesterday on climate change. You may have heard him discuss how these really north-facing slopes are more sensitive to climate change. So we suspect that climate change and habitat alteration may be playing a part in the troubles this species is having. You can see this is one of the native populations. Large flower fiddleneck at Site 300 occurs right here, really deep down in the canyon where it's shaded for a large part of the day, especially in the winter. Okay, so going back to Site 300, this is our remote test site. A little bit about fire at the site. Although there's been no livestock grazing at the site, has been a program of prescribed burns since the site was established in the 50s. And we have records of the burn frequency that date back to the 1970s. So this map is showing the frequency of fire. This includes prescribed burns and wildfires at the site since, I think, since 1978. Although it does include wildfires, I'd say about more than 99% of the burn frequency at the site is prescribed burns. You can see the red areas are areas that have been burned within 26 to 34 years out of the last 36 years. And these dark green areas have only been burned a couple times, once or twice really, within the last 34 years. So these red areas are really showing the areas where they have a program of annual prescribed burns to protect the site from wildfire. And the dark green areas are showing areas that really have only been exposed to wildfires. So here's a vegetation map of Site 300. And what I'd like you to see here is all the areas that are not highlighted are California annual grasslands. These areas that are brown on the map represent perennial grasslands dominated by Poa secunda and Miscella/stipa species.
What are those two species?
Oh, Poa secunda and Miscella pulchra. So if I go back one, you can see that the area of high fire frequency is really highly correlated with the area of perennial grasses, as we would expect. So before I get into our research, I'd like to give you a little background on the historic work that's been done on this species. So there's a long history of research into the ecology and restoration of this species, starting in the 1970s with work that Robert Orndorff did. In the 1980s, Bruce Pavlik did extensive research and work to try to introduce populations of the large flowered fiddleneck throughout his range. And as part of that work, he studied how different treatments would benefit the establishment of populations of the large flowered fiddleneck. And just in summary, what he found is that the use of fire and grass-selective herbicides can enhance the establishment of populations of the species. Research led by Tina Carlson has also been underway at Site 300 since 1992. So this started with a competition experiment to determine how large flowered fiddleneck would survive in populations of perennial grasses and compared to exotic annual grasses. And the experiment was set up with different plots, treatments in different densities of perennial grasses and different densities of exotic annual grasses. And the end result was that, in general, although the large flowered fiddleneck did not do well in extremely high densities of either perennial or annual grasses, it did do better in perennial grasslands, and it did best in these mid-density perennial grasslands. Additional research was conducted to determine how predation impacts the large flowered fiddleneck. And just kind of to go through this quickly, in some years predation is high, and if predation is high, I'm sorry, I should say this is seed predation. Seed predation, in some years seed predation is very high, and the comparison between burned and unburned plots, can't be seen. Seed predation is high in all plots, but in years when seed predation is low in general, there's higher seed predation in burned plots. So we have a little bit of evidence that in burned plots we have much higher seed predation. So now to get to the current research that we're discussing, long-term fire frequency experiment. So we're looking at the question again, can fire be used to enhance the grassland habitat? We know large flower fiddleneck does better in these perennial grasslands. We know fire helps promote perennial grasslands. So can we use fire as a tool to help us establish new populations of the species that's really in trouble? So what we did, this is the introduced population of large flower fiddleneck at site 300. And we set up 2-meter square plots with 4 treatments. There was control that were designed not to be burned after the experiment was set up, plots that were burned every year, plots that were burned every 3rd year, and plots that were burned every 5th year. All plots were established initially with 33 Poa secunda in the center of the plot. And this is the density of perennial grasses that Tina determined was most beneficial to large flower fiddleneck in her previous research. So this is what we found. And this first slide shows the number of Poa secunda tussocks in each plot by burn frequency. And as we would expect, the number of Poa secunda, so the red line is showing the high frequency. These are plots that are burned every year. And Poa secunda is really taking off in these high frequency burn plots. So also on this graph, all plots were initially burned before this experiment was set up in 2000, and the last burn was conducted in 2012. So you can see Poa secunda is really increasing in the burn plots up until we stop the annual prescriber, and then we see a small drop. And the control plots, which are these blue diamonds, really have the smallest number of Poa secunda. Okay, so as far as large flower fiddleneck success, it didn't turn out quite as we would expect. The number of large flower fiddleneck tended to decrease as fire frequency increased. In fact, large flower fiddleneck appeared to do poorest. It did not do well in the highest frequency burn every year plot, and it did best in the control plots. Also, large flower fiddleneck, the size of the plants generally decreased with increased fire frequency, so that the plants that did occur within the high frequency burn plots were much smaller than those that we would find in the control plots. The number of branches is a proxy for the seed production for this plant. So the more branches, the more inflorescences the plants have, and the more seeds it's expected to produce. We didn't see really a significant difference in the number of branches produced by large flower fiddleneck by fire treatment. So, in summary, we know that large flower fiddleneck does not do well with high densities of exotic grasses. We know that fire can be used to promote perennial grasslands, and it decreased the exotic grasses. Intense fire frequency appears to have a negative impact on the success of large flower fiddleneck occurrence, so that burns every 1, 3, or 5 years is just way too often for this species. But fires that are less frequent may have a beneficial impact. That's something we haven't studied yet. And I'd like to thank our funding sources. We've had some funding in the past from the U.S. Fish and Wildlife Service and the U.S. Bureau of Reclamation, but especially the lab is a particularly generous organization in the funding of research into the rare plants that occur on the site.